And we're starting on assignment number 4, which is generically called hatching, although there's more to it than just hatching. I'm going to go ahead and share the screen with you. Okay. This first part is called cross contour drawing. So there's different parts to assignment 4. There's part 1, which is cross contour drawing, and part 2, which will be hatching and cross hatching. But as I said, for this first part, part 1, cross contour drawing, we're going to be using the materials of newsprint and pencil. So again, you want to have about 4 or 5 sheets of newsprint, and you want to have a pencil, and I'll just put in parentheses here, 4B or 6B. And as I said, pressure, or the ability to create light or dark lines with the, we'll call it lightness or heaviness. Is that how you spell heaviness? It looks like it is. Of, and we'll put in quotes, attack, meaning, you know, how aggressively you're pressing with your pencil versus how tenderly you're pressing with your pencil is going to be the method by which we get darker or lighter lines. And as we move into shading, proper tonal work instead of a linear network to create light and shadow, pressure will become important as well. Another aspect of this particular unit is we're going to be using ink. So I need to figure out a good way to get you guys all to have some ink to carry with you. I'll get some little containers, so on Monday you can carry ink home, but I'm trying to figure out how to get it to everybody.
You don't have to worry about me because I have some at home.
Mm-hmm.
At least.
Well, there's one person I don't have to worry about. Thanks, Josh. I appreciate you. We'll figure it out. I'll get you guys ink today before we leave. And then today's Friday. Monday, I'll give Group A some ink. And then we'll see what we can do with Group B. All right, anyway, irrelevant because we're not doing ink today. It's just something that's coming up. So at any rate, as I said, this particular unit is called cross contour drawing. This is going to begin our kind of shift from shape to what we call mass, volume, or more generically, form. So mass or volume can be kind of generically or generally called form. So we're moving away from shape, which is the outer boundary of things, to mass or volume, which is internal. It's more internal. So again, shape equals outer boundary, form equals inner So one thing, shape, especially when it comes to the outer boundary, shape is, when we're using line, we're using actual line because the line is actually there. If we look at an object, oh, here we go. I got to remember not to maximize. So if we think back to what we've been doing with our drawings, we've been concentrating on the contour of the shape, right, which is the outer boundary. It could be an outline or it could be a contour line. Boy, this is really not cooperating this morning. There it is. So if we look at this shape here, you know, the shape is this primary contour. And it's an actual line separating the figure from the ground. Does that make sense to everybody? I'm going to try not to see if that works better. So shape, in the case of what we've been doing, we've been using actual lines in order to express the contour of the figure set apart from the ground, okay? With form, and specifically with cross-contour drawing, so let me be clear, this is just about cross-contour drawing. Is all about implied lines, okay? So there's a difference between those actual lines that we're actually seeing in that form, okay, and lines that can imply the mass of the shape or the form of the shape, okay? Now, the outer boundary, or the actual lines of the contour of the figure, okay, they're part of the form, okay, but they're just one part of the form. In other words, you have to have an outer boundary or a limitation of that shape in order to fill it with lines that imply the mass of that shape, okay? So it's the difference between actual lines and implied lines. So form, in the case of cross-contour drawing, and how we create form, is concentrating our efforts not solely on the contour of the drawing, the shape of the drawing, but also on representing the space of that object. And I put space in quotes, because technically speaking, space is about things that are nearer to us or farther from us within, say, a landscape or a still life, etc. Another word that we could use there is depth of an object, okay? So depth of an object. So when we're creating a form using contour lines, we are kind of giving a representation of depth, right? For instance, our boxes, our cylinders, etc., the way that we're drawing them gives an illusion, even though, you know, we're using actual lines, it's still an illusion of three-dimensionality, but it's an illusion of three-dimensionality based on the contour, the outer boundary, or in some cases, some of the secondary shapes within the full shape, like the ellipse is a secondary shape relative to the primary contour of a cylinder. Is everybody following me still far? Still far? So far, still, so far? Okay, good. So when we're talking about form, again, specifically with cross contour drawing, we're using implied lines to represent the depth or the mass or volume of an object. So dimensionality refers to how much of a space, a given space, an object takes up. In the case of a solid object, like, let's see, what's a good example of a solid object? That would be a banana, okay? That's a mass. A trash can is a volume. Does that make sense to everybody? You know, it has an outer skin to it, a trash can, but inside it's hollow. Does that make sense? Versus a banana, which is solid all the way through. Are you following me? Either one of those can have a dimensionality. Both do have a dimensionality to them. In the case of a trash can, it's a cylindrical volume. In the case of a banana, it's a compound shape that combines a cylinder and a planar form that, when we're using contour lines, expresses a mass. All right? We good? Okay. Anybody online have any questions so far? It'll become clear once I show you. And by the way, you know, when I'm talking, it's much harder to understand a visual thing than if I show you, right? I mean, art is all about visual communication. That's what we're doing. In fact, at some point, most of you will be taking a class, no, all of you will be taking a class, it's required, called Visual Literacy and Communication. Okay? You're already getting training in that right now as you speak, but it's much more complex. Oh, I just did it. Ming, why did you let me do that? Ming. So anyway, contour drawing is more about shape. It's more about the 2D. Cross contour drawing is more about mass or about the 3D. How many times did we figure this out, Josh? It was like 20 times? Huh? This really makes me mad. Can you tell how mad I am, Cassandra? There's got to be a way to do this. What a waste of time. You mean like down here? Yeah, it's full screen though. That's the, oh, there we go. Whew. Thanks, Cassandra, for at least giving us good luck. All right, here's where the rubber meets the road. And I promise I'm not gonna. Okay. Okay, so here we have this cylinder shape. Okay. Can everybody see my paper on Teams? Somebody on Teams, tell me if you can see the figure or not.
Yes.
Okay, good. All right, so when we're drawing a cylindrical shape, we start off with our constructed line. We'll start off with our center line to determine how big we want to make it, right? We determine that this is the height limit that we want to make, and then we start to either make guesses or use measurement to kind of decide, how tall is it. That looks like it's going to be a little bit too narrow, so I'm going to pull out those lines a little bit. Okay, so far we understand. We're concentrating on the primary shape. And then we've got the ellipse. That ellipse looks to be about 1/5 of the width, so maybe about that wide. So I'm going to draw my center line across and draw my ellipse. Okay, so everybody is familiar with that, right? Correct? We're caught up to speed now. So that is a shape. Now we get a sense of mass because of this secondary shape here. If it wasn't for these curves, we would think it was just something flat, right? And it is flat, because it's a representation of space, not actual space. It's two-dimensional, not three-dimensional. It just looks three-dimensional, right? When we get into cross-contour drawing to express mass, we look at lines of latitude and lines of longitude. So latitude lines would be lines that run parallel with the vertical edge of the shape. And you'll notice that I'm making them just as dark as I'm making the outer boundaries of the shape. Does that make sense? Longitude lines are lines that run on the horizontal. And that kind of evoke or are a repetition of the bottom of our ellipse. That's a cross-contour drawing. Does that make sense to everybody? Now it's really hard to do this for me because I'm standing way back here. But to make it finished, if you will, we would then come back in with a darker line really hard to draw from this angle. And we would be a little bit more careful but you notice how I'm using my arm, not my fingers, to draw those lines. And you're trying to kind of generally space it out evenly. Now, on the internal shape, which we haven't even looked at yet, you're going to have the same thing, but they're going to go in the opposite direction as the lines that are on the outside of the shape. Does that make sense to everybody? And then you could also have those latitudinal lines on the inside of the shape because there's a vertical dimensionality there. Does that make sense? Again, sorry for the cattywampusness of this, but you guys know that I'm drawing from a weird angle. So that's going to be a cross-contour drawing of a cylinder, okay? So let me pull this down. Oh, that was nice. And I'm going to open up a little drawing here. So we've heard these terms before, right? longitude lines run vertically, latitude lines run horizontally when we look at a globe, right? And that's how we can find our spot on the globe. Now we have GPS, of course, which makes it very easy. But previously, they used these lines of latitude and longitude and the stars and all of that stuff to figure out where they were on the globe. So longitude, vertical, latitude, horizontal. So here's a little small drawing, not very big, and very pixelated, that shows the latitude lines and the longitude lines in kind of a watermelon-shaped form or an elongated sphere. Does that make sense? So cross contours, these are both examples of cross contour drawings, but cross contour in its fullest sense is a combination of the two. Does that make sense to everybody? All right. Let's pull out a box. Well, that's not going to work until I have my camera up. Oh my gosh. All right. We're going to be aggressive now. Okay? So with a box shape, our lines are going to be obviously different. I'm just going to leave it like that. I don't know if you guys in the classroom can see that as well as you can see it on the computer. Okay, so with the box shape, we're going to have our vertical line, it's the front edge. We're going to look at the side line here. So we've got our primary contours of the right side, and then we've got our primary contours of the left side, and then our primary contours of the inside. So this is going to be a volume, right? Just like the cylinder was, the oatmeal can. Here we're going to have lines that run this way, vertical lines. And we're going to have lines that run this way, quote unquote horizontal. And notice as we get towards the bottom, those lines start to lean a little bit more. Does that make sense? So up here, they're going to be a little bit more similar to that angle. Oops. Sorry. And then as we move down, they're going to start to evoke the bottom angle a little bit more. Does that make sense to everybody? And then inside, it's just going to be a repetition horizontally of that diagonal versus the vertical, right? And then over here, we'll have verticals again. And then this side is going to be an evocation of that. You see how much more dimensional that looks just by adding those contour lines? Like it really gives you a sense of mass and dimensionality. And of course, if we were to combine it with like a contour drawing where the lines got lighter as they went back in space, or faded, it would even give you more of a sense of dimensionality. You see that? Does that make sense to everybody? Now I can do this without even looking at an object. I can just think about, because this is a very conceptual thing. These lines aren't actually there, right? So actual lines are the contour, the secondary shapes, maybe some of the tertiary shapes that we see as far as like the texturing we did in the contour drawing. These implied lines are more conceptual, they're abstract. They're not really there. They're our brain's way of kind of communicating what we're seeing as far as the mass surface. Does that make sense? So you guys should remember this bottle. So here, we're going to have vertical lines. Here, we're going to have vertical lines because these are planes, right? Okay? Here, we're going to have diagonal lines that evoke the bottom of that bottle. And of course, as we get near to this shape, they're going to get shorter, right? This side is going to have diagonal lines that are a repetition of the direction of the bottom that are going to get shorter as we approach this side, right? You following so far? Okay? And then this is a cylinder, right? So we'll have vertical lines, we'll have elliptical lines. Now this shoulder, is it a planar shape or a curvilinear form? It's a curvilinear form, right? So what we'll probably see here are lines that start curving in this direction, so evoking the directionality of that side. Does that make sense? And then as we move towards the middle, they become what? A vertical line, right? Because it's straight in front of us, right? And then as we move in this direction, they become curved relative to this side. Does that make sense to everybody? Now, this those horizontal lines are going to be like a cylinder. Does that make sense? So imagine you're an ant that's like walking across the surface. What kind of, and you have ink on your feet, what kind of lines would that create? Does that make sense? What kind of direction? Now up here, this is a planar form that has a cylindrical quality to it, right? And notice again how towards the middle we've got a vertical, and then as we move out to the side, we start to approach that angle versus this angle, right? And then on the inside, we'll have similar, oops, sorry, I lied, vertical, like that, and then, again, that make sense to everybody? So again, look at how dimensional that shape becomes when we add the cross contour line. Okay? Let's try one more thing, and then we'll do some exercises. Okay? Whoa. What the heck happened to my apple? Okay, it looks okay there. So with the apple, we're going to have kind of a spherical shape at first, right? And then we're going to start to have the more kind of organic quality. It's not really round, right? But I can start off with a mass that's basically round, right? I'm kind of taking this apple as I go. Oh, sorry. Thanks. So you guys out there in Teams land, I'm sorry I didn't have my drawing up, but you can see how I started off with a light gestural circle, and then I came in and started to deal with refining the contours. We've got the stem, and then we've got the leaf. Okay, so that would be my contour drawing of the apple, right? The shape of the apple. Now, if I want to start dealing with cross contour, to me that side of the apple looks kind of flat. And then it becomes kind of round through here. And then it becomes kind of flat again. Then we're going into that little cavity of the apple. You see that? Now these lines are not going to be straight, right, because it's a curvilinear form. And as we get towards the middle, what's going to happen to the line? But it's going to become straight, right? And then as we go in this opposite direction, it's going to be more conformed to the outer edge of that boundary, right? Okay? You see how I'm thinking about the cross contour there? Yes? Now the stem is going to be like a cylinder, right? And then the top of it is flat, so it'll have straight lines on it. Right? And then the leaf, is it a planar shape or a cylindrical shape? The leaf, is the leaf a planar shape or a cylindrical shape? Is it a plane or a cylinder? The leaf is? It's a plane, right? The stem is a cylinder, the leaf is a plane. Does that make sense? So we would probably see something like this. And then we would see something like that. Does that make sense to everybody? We won't start with that. We'll start with it. Okay? Anybody on Teams have a question? Okay. Is Teams people still out there? Alexa, are you there?
Yes, I'm still here.
Okay. So you have any questions?
Not so far, no.
Do you have any questions?
Not so far.
Kaylee, do you have any questions?
No, I'm good.
Not allowing us to hear you. Kaylee, try it one more time.
Can you hear me?
You're not, I haven't muted you. Okay. As usual, we're having technical difficulties. All right, so what I want us to do is those of you at home, I want you to open up your reference photos, the first email that I sent, and I want you to look for this bottle. Okay, so this is the bottle that I want us to be drawing. And I'm going to set it up in the classroom as well. And we're going to spend some time doing a cross contour of this bottle. I want you to make it as big as you can on the page, just like we've been doing previously, without actually going off the page. Does that make sense, everybody? So, pencil, 4B or 6B, newsprint, and draw this bottle. Do what? I can't hear you. 4B or a 6B pencil? No, just start with the 4B or the 6B, but use light pressure. And, you know, as far as like neatness is concerned, this is really a preference. So you don't have to be like really precise. I'm more gestural with my cross contouring. But you do want it to be kind of regularly spaced as far as the grid that you're laying over the top of it. Does that make sense? And I say kind of meaning generally. It doesn't mean you have to like get out a ruler, although you could do this with a ruler, right? But that's not really the assignment. Which makes drawing it, you know, with the qualifications of having it be as big as we can make it without going off the page, more, I guess, achievable if we turn our page on its side as opposed to having it vertical. Does that make sense to everybody? So there's a format assessment. Format refers to vertical versus horizontal. Now, let me ask you a question. Is this shape rectilinear or curvilinear? It's rectilinear. But does it have a curvilinear kind of quality to it? It has a kind of roundness to it, yes? So what I would probably do if I were drawing it is I would start off kind of estimating how wide I want it to be. So that's about how wide I want it to be, okay? And then I'm going to say, okay, if I drop a center line down here, how big is the top relative to the height of the front? What's your estimate on that? Ryan, what is your estimate on the height of the top relative to the height of the side in my photograph?
Maybe like 1/4 or 1/5 of the height.
Okay, let's test this theory out. So if I take this and make a box out of it, okay, that's the height of that, right? Does everybody see that? And now I move it down. What's the relationship of the height of the ellipse relative to the height of the front? It's the same length. So if I was to come over here on my drawing and say that this is the height that I want to make it, where's the front edge? Right there. That's the front edge of the ellipse, right? Because that's halfway of the vertical line that I've drawn, right? Now, how would we determine the width relative to the height? So that's the width, right? Let's see, what's a cute way of doing this? Oops. How do I rotate the object? Rotate right. No, that didn't do what I wanted it to do. Yes. Something like that, you're saying?
Yeah, and then once you have it on, it should let you rotate.
Yeah, it's not. Oop. No, it's not going to let me. The point I'm trying to make is, what is this height relative to that width? Well, to me, if I measure it, it looks about equal to me. Maybe a little bit shorter. Does that make sense? If I measure it. So is this, equal to this? Probably not. Probably need to pull it in a little bit. So I'm going to pull in those sides. So there's my guess as to the height, width, and the location of the height, the bottom edge of the ellipse. Does that make sense? So the next thing that I would do is just make it a cylinder.
The teams cover. Yeah, the teams cover.
Sorry. So I would just make the object a cylindrical shape. You see what I mean? Because that's simplifying it a lot more to me than trying to get involved with all of those facets right away, right? Now in this photograph, where is the center of that shape? That vertical line is where relative to the left and the right? It's about half, right? So if I make this that line, right? Then all it is a matter of measuring angles. Now if I estimate how big this shape is, where's my relative to that? Is it here? Is that where it is? Huh? What do you think? Do you think that's where it is? Does it need to go more to the right or more to the left? More to the right. Okay, how about right there? Does that look about right? Okay, let's try it. So if this is our edge, does that look about right? Yeah, it does. And what about the other side? Is it the same width? it's a little bit, this side over here, is this the same size as that? It's a little bit narrower, but not by much, right? So just a little bit narrower. So if I make it the same and make it a little bit narrower, now I'm cool, right? Does that make sense? Now all I got to do is find those edges here. I got an angle like that, right? Same thing over here. Are we following me? Then the top edge is going to be a similar angle. This is going to be a slight angle. Are you following me? You see why I did that? Now remember, we got to make it fit. No, that's got to be steeper. You see how I'm thinking about it that way? Huh? You know, how can we figure out the location of that point? Well, we could triangulate, right? Right now, I'm just kind of guessing. But I'm thinking of it as a cylinder first. Does that make sense to everybody? All right. And then, of course, we would come in and estimate right, the height of this thing. Does that make sense? All right. All right, try that shape. Yes.
You know how like you said like the cylinder wise and stuff, but you know how you start off with that middle line to kind of go up to make it proportional for your sides and stuff.
Uh-huh.
If you don't, like you know how the picture it has that middle line is in the picture, but here's an angle like iron and your face is the middle. How do you just like throw it up? Yeah.
Okay, so with that, and I'll draw it up here, I would, you know, give my height, and obviously the top is actually now shorter than the front. So if this is my height, then the top should be shorter, not halfway, but shorter, right? Does that make sense? Now the height relative to the width, it's about half. So the width is twice the height. So over here and over here, right? So now we've got the shape. It's got to fit within this box, right? All right, so this is below the top. So it looks to me, from your point of view, that that square is a little bit to the left of the center of the shape. So if I find the center of the shape, you know, this is a little bit, that side is a little bit on the other, the left side of my center line. So what I'm doing is I'm dropping a vertical down the middle of the shape, and I'm seeing, you know, what's on the left side versus the right side.
So you get like look at it and stuff, you divide it like even if it has that good line, divide it with,
Correct. All this is determining is the height. It has nothing to do with the internal secondary shapes. Does that make sense? And then I would come in and do something like this. And I say, oh, that seems like it needs to be a little narrower. So I'm going to move that over to narrow that up. And then I've got, and all I'm doing here is measuring my angles, right? As far as that's concerned. Then that tiny little shape that's over there. Does that make sense? But it's still a cylindrical shape. You know what I mean? Good. Mhm. Is it this line or this one? This line? Yeah. I think it's probably that line is too wide, and that those lines are too shallow. Does that make sense? Because our tendency, for some reason, is always to move them closer to horizontal. I don't know why that is. It's just, it's uncomfortable for something to be moving away from you. But, you know, if I mean, maybe even be a little bit steeper than that. You follow what I mean? If I'm here, it's going to be more like that. If I'm here, I'm not going to see it at all. If I'm here, it's going to be just past vertical, and I'm just going to see a little sliver. So let's see. So that's good, the placement there. So that means that, you know, we should get along with something like that. It's still off. That line's good. Wow. That looks better. You see what I mean? So this was in a slightly incorrect place. That was in a slightly incorrect place. Just slightly, right? Not horrible. That's good. See how we're just kind of shifting stuff around. Okay? So this is nothing.
Yeah, let's just go with the middle one.
Good. So to me, the top is not quite as curved as you make it. I think these would be more straight. It's not like a huge dome. And then I think you could probably get away with doing this. And then, no, I actually, or you should choose this side. That looks like it. And then probably here, it's got kind of like a curve, you know what I mean? Kind of roll to it, so you can do that to get a little bit more roundness. I think the main thing is this one needs to be more vertical. As does this, if they're relieved a little bit. That one is more in. And then if I look at the relationship between here and this one, I get slightly angled relationship like that. But that's where that comes from. Then I go on to be in this direction. Now I'm trying to find that. So that just happened to be where it needed to be. And the next line, you're good there. Good. good, you know you're good there. But this looks like it should be a little bit thinner. And the way that we can tell is we can triangulate between those 2 points. And actually, it's a little bit to the left of that. In other words, it's not directly underneath it. Does that make sense? And then we've got a slight angle down. And we can get this angle. See what I mean? Now we want to figure out where that one is. So we can triangulate from there to there. And I'll go down like that. Which means that that's where. This is where you're going to put it handy. Did I give you guys some? Oh, okay. Doesn't that look better? You see how I'm using the triangulation? Does that make sense how I'm doing that? It's okay, it's okay. So one thing that's really helpful with this is take this line, which you've established, and figure out where this point is. Okay? So what I can do is I'll take this and I'll triangulate to where it is. Is it above, slightly to the left, way to the left, I don't know. So it's definitely to the left, and I'm seeing an angle something like this. So good 12, 11, 10, somewhere about 10:30. So make a mark, and I go in the direction of that mark, so right there, and I know that this has to be a straight line. Does that make sense? Now I find the next one. So I lay it on that corner, I rotate, that's about the angle. So 12, 1, 2, about 12:30, maybe 1 o'clock. Okay? And that's right there, right? And then it's just a matter of on a straight angle. And then I do the next one. You follow what I mean? Triangulation is key in this type of shape.
So I'm still going along with you based on that. Now,
So it's not that.
yeah, is this really on the top?
No, I think what I would do is like this.
Okay. All right. Yeah, at first what I was doing, you can see a little bit, I started going to that side.
And you could do this too. So basically, I'm just repeating one of the edges. That makes sense? Either which way you go, it still helps to lay down flat, whereas these lines tend to pop it up. So, all right, hold on 1 second. What time is it? Tell me what time it is. 44. Okay, I just want to talk real quick about the top of this thing because we had some questions. So you guys on Teams, look at the screen. I'm still recording, which was pointless. So you've got my shape here. And again, you know, one of the things that we discovered was, you know, that triangulation is really important. So finding this point and making sure that that angle is correct. Or to find this point, looking for this angle. So again, you know, if we're going to find this point, does the angle that I just drew match with that? Yeah, it's pretty good. It's just to the left of vertical. So if this is vertical, that line should be just to the left of vertical, you see? But the question was, and Joshua asked this question, he said, so, you know, this is easy enough to understand, right? And this obviously is going to have vertical marks like this. These marks are going to move 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 like this. And these marks are going to move like that. Okay, so we got that. But what happens if I do this? What happens to that top? What does it look like? Does that look like that top is laying down? No, it looks like it's flipping up. It becomes perpendicular to our line of sight, not parallel with our line of sight, moving away in space. Huh? It almost does look hollow, doesn't it? Yeah? And, you know, like if it was hollow, we could probably have, you know, something like that happening, right? So that we could see the inside, right? So it's not. So how do we determine what direction? Well, we can go any direction of one of those edges. So I'm taking this angle and I'm simply mimicking it until I get to the other side. Does that help it feel like it's laying down now? We could do that, or we could do this. Or we could do this. Or we could do this. Or we could do, you follow what I mean? You can go in any direction of any one of these diagonal edges, and it's going to make the top feel like it's laying down. You see that? So you can do just one or all of them that way. But that's going to give it the sense that it's a solid plane moving away from you in space. All right, so just to let you know what your homework is, and we're going to do things a little bit differently this time. We're not going to turn these into a discussion group. So over the weekend, find 5 objects that are 1, curvilinear, 2, rectilinear, 3, cylindrical, 4, compound, and 5, compound complex. Now, what the heck does that mean? Well, this would be kind of like a compound complex shape, right? Or, let me see if I can't show you another compound complex shape. This would be a compound complex shape. Okay? Does that make sense? Because it has those tertiary inner ribbings. So you're going to do 5 drawings, 1 each, of each one of those shapes. Okay? And then you're going to email them to me by the beginning of class on Monday. Title them as follows. First name, last name, number 1. First name, last name, number 2. First name, last name, number 3. First name, last name, number 4. First name, last name, number 5. Clear? So you're not uploading them to D2L. You're just emailing to me. And while we're at it, let's say in the subject line, write cross contour homework. Okay? Anybody online have any questions?
I have a question.
Sure, go for it.
So are we just taking photos and sending them to you, or are we actually drawing the objects we've found and then send them to you?
Does that help, Jonathan?
Yes, sir. Do you want the reference photos as well?
No, I just want to see the cross contour drawings.
Okay,
Okay?
thank you.
I'll get really specific. In your sketchbook using 4B or 6B pencils. All right, folks, have a good week and stay safe. We'll see you on Monday.
Have a good day.